CSEC AdMath 2024 exam. Let's get straight into it. Question 1. Determine the other linear factors of the polynomial 3x cubed plus 8x squared minus 20x minus 16, given that x minus 2 is a factor. So if x minus 2 is a factor, we can divide the function or the polynomial by x minus 2, and the quotient should give us the other factors. So we can either use long division, or I'm going to be using synthetic division. And how it works, so it forms something looking like almost like a L. We're dividing by x minus 2, so I change the sign of negative 2, so it's plus 2, right? In the L, inside we put in the coefficients of the polynomial, so 3, 8, minus 20, minus 16. So we bring down the first value, positive 3, multiply by the value outside here 2, 2 times 3, that's 6. 8 and 6, 14. So 2 times 14, that's 28. Negative 20 and 28, that's positive 8. 2 times 8, that's 16. Negative 16 plus 16, that's 0. And the final value represents the remainder. And we expect it to be 0 since x minus 2 is a factor. So the remaining values would represent the coefficients of the quadratic, the quotient. So the quotient is 3x squared, plus 14x plus 8. But this is a quadratic factor. So we need to factorize this to get the other factor. Let's factorize this. So the other factors, by factorizing this quadratic. And to factorize this quadratic, we can use what we call the AC method. AC, that's 3 times 8, 24. So we want two numbers that multiply to give 24 and add to give 14. That's 12 and 2. So this would be 3x squared plus 12x. So rewrite the 14x as 12x plus 2x plus 8, and then we factor by groups. So we factor out 3x as a common factor, and we are left with what now? X plus 4. The other pair, common factor there is 2. Again, factor out 2, we have x plus 4. So the other factors are the common bracket, x plus 4, and we are left with 3x plus 2 outside of these brackets. So those are all other factors, x plus 4 and 3x plus 2. Part B, we're asked to simplify this expression. So 3x cubed plus 8x squared minus 20x minus 16. We just factorize it completely. So we knew one factor was x minus 2. So we're going to rewrite the numerator here in terms of its linear factors. So we know x minus 2 was a factor, and the other two factors were x plus 4 and 3x plus 2. So we rewrite the cubic polynomial there in terms of its linear factors. In the denominator, there's a difference of 2 squares. It's x squared minus 2 squared. So we can factor the denominator as x minus 2 times x plus 2 times, and we have x plus 2 times x plus 4. And we can divide out several things now. So x minus 2 into itself, x plus 2 in this denominator leave us with 1, divide into x plus 2. Up here we are left with 1. X plus 4 into itself, there is 1. Divide x plus 4 up here. 1, so all we're left with is 3x plus 2 over 1, which is just 3x plus 2. Part B, the equation kx squared plus x minus 15 equals 0 has roots alpha and beta, where k belongs to the set of whole numbers. Determine the expressions alpha plus b. So alpha plus b, that's a sum. So alpha plus b, that's a sum. And the sum, by the way, the sum of the roots of the quadratic, the sum is what? Negative b over a. And we know the product of the roots of a quadratic is c over a. So here a is k, this is 1x, so b is 1, and c is negative 15. So alpha plus beta, that's negative b over a, b is 1, so it's negative 1 over a, which is k, the x squared coefficient, right? And the product of the roots is c over a, the constant c there is negative 15, so negative 15 over a, which is the x squared coefficient, that's k also. Part 2, given that alpha squared plus beta squared equals 61 over 4, use the expressions in B part 1 to determine the value of k. Now we know that alpha plus beta all square is alpha square plus beta square plus 2 alpha beta. So we expand alpha plus beta times itself alpha plus beta. We'll end up with this. And we know that alpha plus beta is negative 1 over k. So in the bracket here, that's negative 1 over k all square. Replace alpha plus beta with what it represents. And alpha square plus beta square, we're told, is 61 over 4. So we can replace these two terms with 61 over 4. And then alpha beta plus 2, and alpha beta is negative 15 over k. So straightforward substitution, replace alpha beta with negative 15 over k. So let's see what we can do with this now. So if we expand, this is multiply this by itself, we get 1 over k squared equal 61 over 4. 2 times that, that's negative 30 over k. And now we need to get rid of the denominator. So we can multiply both sides by the LCM. The LCM in the entire expression is 4k squared. So we're going to multiply each term by 4k squared. So 4k squared. So multiply this by 4k squared. We're left with k squared, cancel k squared, so we're left with 4. Multiply this by 4k squared. Multiply by 4k squared. 4 into itself, cancel. So we're left with 61 k squared. Multiply this by 4k squared, so we multiply each term on both sides by 4k squared. Negative 30 times 4, that's negative 120. And k into k squared, that's just k. So we end up with a quadratic. So to solve the quadratic, we want to group everything on the one side. So we can just group the 4 on the right hand side. So we end up with 0 equal to 61k squared minus 120k. Group the 4 on the other side, that's negative 4. And we need to solve this quadratic now. So we can use the quadratic formula. K is minus b plus or minus square root b squared minus 4ac all over 2a, where a is the k squared coefficient, b is the k coefficient, and the constant c there is negative 4. So we substitute these in the quadratic formula. So b is negative 120. So negative b is negative 120. That's positive 120. Plus or minus the square root of b squared. That's negative 120 squared. minus 4 times A, and A is what? 61 times C, and C is negative 4, all over 2A, and A is 61, so all over 2 times 61. So we end up with K equal to 120 plus or minus. Now everything under the square root works out to be 15,000, square root of 15,376, all over 2 times 61. 2 times 61, that's 122. Oh, what a space here. So therefore K is equal to 120 plus or minus the square root of 15,376. That's 124 over 122, which means that K is equal to 120 plus 124 over 122, or K is equal to 120 minus 124 over 122. So K equal to, no, 120 plus 124, that's 244 divided by 122, that's 2. Or here K equal to, this is what? Negative 120 take away 124, that's negative 4 over 1. So this value will rule out. So this is not a solution. Remember, the question had told us that K is a whole number. So our solution here is 2. Part C, for the quadratic function g of x equal minus 5x squared minus 4x plus 2, determine the exact value of the maximum point and the range using the method of completing the square or otherwise. So we're going to rewrite the function by completing the square. So the function g of x, we rewrite it. So we're going to factor out minus 5. So we factor out minus 5. And of course, to get the terms for the bracket, we divide each of these terms by minus 5. So we end up with x squared divided by minus 5. That's 4/5 x divided by minus 5. It's minus 2/5. So remember, to factorize, to complete the square, we first need to factor out the x squared coefficient. In this case, is negative 5. So let's complete the square now for the expression in the bracket. So of course, restate our minus 5 under a square bracket. So we're going to form our square. X, follow the sign positive, and we take half of 4/5, and half of 4/5, that's 2/5. So we start like that, minus the square of the constant there, so we square 2/5, we get, so we have minus 4/5, well, 4/25, so square 2/5, 2/5 times itself, that's 4/25, so we subtract 4/25, and then we restate our minus 2/5 there, so we end up there, and then we can distribute the negative 5 outside of the square brackets now, so negative 5 times x plus 2/5 all square. Negative 5 times negative 4/25, that's actually positive 4/5. And negative 5 times negative 2/5, that's actually positive 2. So this is minus 5 x plus 2/5 all square. We're adding these two values now. This is 2 1/4, and 2 1/4. 2 1/4 is the same thing as 14/5. So when the question has asked us to determine the maximum point, and we know it's a maximum because the x squared coefficient is negative. And now when the x squared coefficient is negative, it's a maximum. Right, so the maximum point is, so maximum point is whatever value makes a bracket 0, that would be negative 2/5 for the x, and the y coordinate is what we have here, 14/5. So that's the maximum point. So we're saying that 14/5, or you say 2 4/5, is a maximum value for is a maximum y value. So the range would have to be then y would have to be less than or equal to 14/5. Since 14/5 or 2 4/5 is a maximum value of y, then y, all the y values would have to be less than or equal to 2 4/5. So that's the range, and the range is just the y values we give, domain x values. Alright, so let's continue. Question 2. Write the expression 2 log x base 3 plus 2 minus log y base 3 as a single term. So the log, so we can rewrite log, this is base 3 x, and one of the laws of logarithm, the coefficient here can be the term moved to the power of the term that you're logging. We need to rewrite positive 2 as a base 3 log, and that's log 3, and we know 3 to the power 2 give 9. Alright, so we rewrite log 2 as log 9 base 3, and now we have log y base 3. Alright, so we can separate like that. We know the laws of logarithm that says log a plus log b is log ab. So since we're adding, we can combine both logs by multiplying. So we can multiply x squared and 9, so this log of 9x squared base 3 minus log of y base 3. And another rule of log says log a minus log b is log a over log b. So we can, since we're subtracting, we can combine both logs by dividing. So when you're adding, as in the bracket here, we combine them by multiplying, and when you're subtracting, you combine them by dividing. So this is 9x squared over y base 3. So that's how we combine these as a single term. B part 1. By using logarithms, express v equals 7 times 5 to the power of t as a single log. So what we can do is log both sides. I'm going to use natural log. So ln v equal ln. So we log both sides. 7 times 5 to the power of t. And of course, this becomes ln v equal, and then we can separate them. This is a product. We can separate them as two different logs by adding. So ln 7 plus ln 5 to the power of t. Since log ab is log a plus log b, right? So that's the principle we applied there. And we can go even further. This is ln v equal ln 7. And the power here can move to be the coefficient. So this is plus t ln 5. Hence, state the value of the gradient of a line which represents the relationship in B part 1. That's B part 1. So the gradient, of course, so this is gradient. So this is, let's refer this as, so no, it's normal in the form y equal mx plus c. So we can match this as the y. Log 7 is a constant. So this will be a constant. and mx. M is a constant, and we refer to t as x. So we assign the variables y as log v, constant there by itself, that's log 7 is a constant. Log 5 is also a constant. So the gradient would be the t coefficient. So m, the gradient, would be the t coefficient, which would be log 5. Part C, we're asked to rationalize the third here, so we're going to multiply numerator and denominator by the conjugate of the denominator. So the conjugate here is 3 plus root 2. So to keep the fraction equivalent, we'll multiply numerator by the same 3 plus root 2. So let's expand. In the numerator, it's 1 times 3, that's positive 3. 1 times root 2, that's root 2. Then the root 2 times 3, that's 3 root 2. And root 2 times root 2, that's 2. All over the denominator, 3 times 3, that's 9. 3 times root 2, that's 3 root 2. Negative root 2 times 3, that's negative 3 root 2. And negative root 2 times root 2, that's negative 2. So the two middle term will cancel. So the denominator here is 9 take away 2, which is 7. And in the numerator, we group it like terms, 3 and 2, that's 5. And we have 1 root 2 plus 3 root 2, that's 4 root 2. Part D, the summation of 5 to the power of I minus 2, and it's from I equals 0 to I equal to 4, so we're going to substitute I values from 0 to 4 and sum our results. So we sub 0 for the I, we get I to the power of 0 minus 2, which is minus 2. We substitute 1 for the I, we get 5 to the power of 1 minus 2, that's negative 1, plus 5. We replace I now with 2, that's 2 minus 2, which is 0. Replace I with 3, that's 5 to the power of 3 minus 2, which is 5 to the power of 1. Replace I with 4, that's 5 to the power of 4 minus 2, so that's 5 squared. So we sum all of these, so 5 to the power of minus 2, that's 1 over 5 squared, which is 1 over 25. 5 to the power minus 1, that's 1 over 5. 5 to the power 0, that's 1. 5 to the power 1, that's 5. And 5 squared, that's 25. Add all these values, we end up with, so 5 and 25, that's 30. And 1, 31. So 31 and 1/5. And we can convert this to a denominator of 25. So it's 31 and, this is what, 6 over 25. So that's 31 and 6 over 25. Is there a solution? Part E. Determine whether the following sequence is divergent or convergent. Justify your response. So this sequence is obviously a geometric sequence where the R value here is, the R value here is negative 2/3. That's a GP. So it's a GP. It's a GP. Sequence is a GP with the common ratio R is equal to negative 2/3. So can I just write a little statement here? Since the absolute value of R is less than 1, then the sequence is divergent. So there's a statement there. So once it's a GP, where the absolute value of R is less than 1, then we have a divergent sequence. Let's move on to question 3.